Let me be clear, I'm sick and tired of all the YouTube panic about AI ending the world. And, let's be honest, this is the only thing we are hearing these days. Before the Wall Street crash of 1929, Joe Kennedy famously said that, "When shoeshine boys give you stock tips, it's time to get out of the market." Fast forward to 2026, and now even fitness influencers and your uncle with the questionable Facebook profile are sharing opinions on Opus 4.7 while worrying about the risks of cloud mythos. But I like to keep things fresh and original on this channel, so in this video I'll give you something much more fun and exciting to worry about. Because if you've been busy following the AI end of the world, you might have missed the quantum computing end of the world. To be fair, quantum computing is not in the news that much, mostly because everyone's too busy watching whatever Dario and Sam are doing this week to 10x our productivity and our anxiety. However, serious companies like Cloudflare, which actually operate real services and carry significant responsibility, are already making concrete changes to prepare for a post-quantum world. So in this Monday morning review, we'll stop talking about AI for once and look in detail at the current status of quantum computing and its potential to change the tech world in the next few years. First, let's make sure we are all on the same page and quickly go through what quantum computing actually is, because at its core, this is a completely different way of doing computation. As we all know, our phones, laptops and server farms burning through a small country's worth of electricity to generate Claude's responses run on classical bits. Every operation, no matter how complex it looks on the surface, is just a long chain of flipping bits between 0 and 1. This is deterministic, predictable, and, most importantly, stable. Quantum computers, on the other hand, use qubits. And qubits, thanks to the beautiful weirdness of quantum mechanics, can exist in a state called superposition, which means they're kind of 0 and 1 at the same time until you actually measure them. If this doesn't make any sense, don't worry.
Here's my goal. Right now, I am the only one who doesn't understand quantum mechanics. In about 7 days, all of you will be unable to understand quantum mechanics.
The important thing is that if you chain enough qubits together and get them to cooperate, which is roughly as easy as herding cats that are also on fire, you can solve certain classes of problems exponentially faster than a classical computer ever could. Notice I said certain classes. A quantum computer is not going to render Cyberpunk at 240 FPS, and it's not going to make AI cheaper. I know I said that we'll not discuss AI in this video, but bear with me for 30 seconds because I have to mention this. Now that the current AI attention-based architecture is showing its limits and the models are plateauing, it's becoming very obvious that we are nowhere near AGI. As a result, some AI specialists are now pushing the narrative that the next step towards AGI is to just plug quantum computing into AI.
I think with AI, especially when AI gets attached to quantum computing, we're going to have an undeniable access to truth.
This is completely wrong. Remember that I said quantum computing works well with certain classes of problems, and it does not map cleanly onto how modern models are trained. Current AI training is dominated by dense linear algebra with matrix multiplications, gradient descent, and backpropagation. These are extremely well optimized on GPUs and TPUs, and quantum computers do not naturally speed up these operations in a practical end-to-end way. So just keep that in mind the next time a crypto bro will tell you that quantum is the next step in AI development. What quantum computing is terrifyingly good at is a very specific category of math problems. And here's where we get to the part that should make you mildly panic. Back in 1994, a guy named Peter Shor published an algorithm showing that a sufficiently powerful quantum computer could factor large numbers in polynomial time. And the problem is that all of the modern internet security relies on encryption schemes whose entire safety is based on the fact that factoring large numbers is really hard. Shor's algorithm says that on a quantum computer this is not hard anymore, and it is actually trivial. So, in a nightmare scenario, someone manages to build a sufficiently powerful quantum computer which can make every RSA key, every elliptic curve signature, and every TLS handshake protecting the internet completely useless. However, the good news is that companies like Cloudflare are already preparing for this event. But before looking at the solutions in more detail, please let me tell you a few words about today's sponsor, BetterDB. BetterDB is a monitoring and observability platform for Valkey and Redis. If you are not familiar with it, Valkey is a high-performance, fully open-source Redis fork backed by AWS, Google, and Oracle. Built by the former engineering manager of Redis Insight, BetterDB fills the gap that every team running Valkey or Redis eventually hits. The data you need to debug an incident is ephemeral, and by the time you're looking for it, it's gone. Memory spikes, latency goes through the roof, connections explode, and when you open CloudWatch or start digging with Redis CLI, the only useful data is already gone. BetterDB fixes that by doing one simple thing properly. It persists the data that actually matters. This goes beyond metrics and dashboards, and you now can see which client executed which commands, against which keys, and with what latency. On top of that, managed services like Elasticache or MemoryDB are supported through an agent that runs inside your VPC, so you don't have to punch holes in your infrastructure. BetterDB is free to start, the setup is trivial, and you can check out the link in the description if you want to find out more about their offering. Back to the video, Cloudflare just published a pretty fascinating roadmap post earlier this month, where they announced they're now targeting 2029 to be fully post-quantum secure across their entire product suite, and that includes post-quantum authentication, which, as we'll see, is the part that should actually keep you awake at night. They shipped free universal SSL back in 2014, started their post-quantum migration in 2019, and by 2022, they had already enabled post-quantum encryption for every website and API on their network. Over 65% of human traffic going through Cloudflare is already post-quantum encrypted. This seemed like a pretty good pace, but now they are forced to accelerate because of a few announcements that happened in the last couple of weeks. First, Google dropped a paper saying they had drastically improved the quantum algorithm to break elliptic curve cryptography. Of course, no one is actually making their discoveries public these days, so Google didn't publish the actual algorithm either. Then, the same day, a company called Oratomic published a resource estimate for breaking the P256 elliptic curve on a neutral atom quantum computer. The number they landed on is roughly 10,000 qubits. The consensus a couple of years ago was somewhere in the millions. Oratomic, by the way, also did the responsible disclosure thing and intentionally left out the crucial details. So we now live in a world where two separate groups in the same week essentially said, "We figured out how to break the internet, and no, we will not be elaborating." Quantum computer scientist Scott Aronson predicted exactly this at the end of 2025, when he said researchers were going to stop publishing these estimates because it hands too much info to adversaries. But why is all of this happening all at once? Breaking cryptography with a quantum computer requires progress on three independent fronts: hardware, error correction, and the algorithms themselves, and progress on any one of them multiplies the progress on the other two. The hardware side finally unstuck itself, with neutral atoms in particular scaling way better than anyone expected. On the error correction side, a traditional superconducting machine needs roughly 1,000 physical qubits to get one logical usable qubit. Oratomic's neutral atom approach needs about 3 or 4. Finally, on the software side, Google's breakthrough massively sped up the algorithm itself. Stack all of this together, and every prediction that said Q-Day was comfortably in the 2035 to 2040 range, just aged like milk. Now, here's where the Cloudflare post gets genuinely interesting because they make a point most people completely miss. For the last few years, everyone has been obsessed with harvest now, decrypt later attacks. An attacker records your encrypted traffic today, sits on it for 10 or 15 years, and then the day a quantum computer works, they decrypt everything retroactively. That's a real threat, and it's why companies rush to deploy post-quantum encryption first. But if Q-Day is actually close, the priority shifts dramatically because the much scarier problem is authentication. Every TLS certificate, every code signing key, every SSH key, every root certificate your browser trusts, they're all protected by signatures a quantum computer can forge. And with a forged signature, an attacker can impersonate your bank's server and sign a malicious update that your laptop installs automatically. And long-lived keys are the worst offenders here. Root certificates live for decades, and code signing certs sign software that's installed for years. If a quantum attacker cracks one of those early, scarce, expensive quantum computers and points it at a high-value, long-lived key, they get persistent, indefinite access to all sorts of fun systems. And, what's worse, even rolling out post-quantum signatures isn't enough. You also have to actively disable the old quantum vulnerable ones, otherwise attackers just force a downgrade. And then, every password and token that ever passed through the old system has to be rotated because you have to assume it's already been captured. So there you have it. One more thing to worry about. Please don't forget to like and subscribe if you want more anxiety-inducing content, and until next time, thank you for watching.